Hello, ladies and gentlemen. Today we're going to look at verifying trigonometric identities. The notes give you some guidelines for verifying trigonometric identities, and the first part of those guidelines would be to pick one side of the equation, usually the more complicated side, and take that side and transform it into the simpler side. Okay? All right? And you can use known identities, any algebraic skill that you know, any property of the real number system to transform the side you start with. You can't even work on both sides, by the way, so leave the other side alone. If you get stuck, then transform all terms into sine and cosine. All right? So let's go verify some identities. All right, let's start with example 1. And when you verify, you prove an identity. And we're going to prove that the secant of t is equal to the cosine of t plus the tangent of t times the sine of t. Well, naturally, the more complicated side is that right-hand side. And I don't see anything that I could do with using any of my known properties or identities that I've learned previously. So what I would do is to go to step number 3, all right, which is to write everything in terms of sine and cosine. Well, that first term is already the cosine of t, all right. Let's write the tangent of t as the sine of t divided by the cosine of t. We still have to multiply that times the sine of t, all right. And when we do, that gives us the first term, the cosine of t, plus, all right, if you want, make sine of t a fraction, take the product of the numerators to get your numerator, and that would be the sine squared of t, and then take the product of the two denominators to get your denominator, and that would be the cosine of t. All right. Now, that's two different terms, and when I look at the left-hand side, there's only one term over there. So what I would want to do would be to combine both of these two terms into one. Well, that means I need, since this one's a fraction, that means I need a common denominator. And I'd like for both of them to be fractions, so that's what I'll do. All right, and my common denominator could be the product of these two denominators, which is the cosine of t. Well, if I want to make that denominator the cosine of t, I'm going to have to multiply both the numerator and the denominator by the cosine of t. When I do, that numerator would give me the cosine of t squared divided by the cosine of t. All right, plus the sine squared of t divided by the cosine of t. All right, and now I've got two fractions with the same denominator, namely the cosine of t. That means I can combine those into one with that common denominator being the denominator. And my numerator would be the cosine squared of t plus the sine squared of t. And when I write the cosine squared of t plus the sine squared of t, I'm immediately remembering my Pythagorean identity. That simply equals 1. So 1 divided by the cosine of t is what that right-hand side would simplify about to. And the reciprocal of the cosine is the secant of t. So we would be done. All right, using our reciprocal identity for the reciprocal of the cosine. And now we have proven that the secant of t is equal to the cosine of t plus the tangent of t times the sine of t. Okay, turn the page. Number 2, we're going to prove, all right, we're going to prove that the sine of theta divided by the cosine of theta plus the cosine of theta divided by 1 plus the sine of theta is equal to the secant of theta. Well, what I would like to do first would be to get a common denominator, because I'm looking over there, there's only one term, and there's two over here, all right? So I'm going to get a common denominator, and it would be the product of these two denominators. So I'm going to rewrite both fractions so that I have the product of these two denominators as the denominator. all right, and that would be the cosine of theta times 1 plus the sine of theta, all right, the cosine of theta times 1 plus the sine of theta. Now, if I look at this common denominator, what factor is missing in this first denominator? Well, it's this right here. So I'm going to have to do the sine of theta times 1 plus the sine of theta. And really, what happens is these two really cancel each other out, which gives you what you had to start with, all right? But we need to get these two fractions combined into one, so we're going to leave that like that for a second. And over here, if I look at this common denominator, what factor is missing? Well, that's the cosine of theta. So I've got to multiply this cosine of theta by the cosine of theta. When I do, I get the cosine squared of theta. All right. And now I'm going to go ahead and distribute over here. And when I do, I'm going to go ahead and add it to this numerator and get that common denominator, the cosine of theta, times 1 plus the sine of theta. All right, so this times this is the sine of theta, plus this times this is the sine squared of theta, all right, plus the other numerator, which is the cosine squared of theta. And now when I look and I see the sine squared of theta plus the cosine squared of theta, that's a Pythagorean identity. I know immediately that that is 1. Okay, so I can rewrite that numerator as the sine of theta plus 1 over the cosine of theta times 1 plus the sine of theta. All right, and now the sine of theta plus 1, that's the same thing as 1 plus the sine of theta, and you could rewrite that step if you want to, or you can just divide both the numerator and the denominator by 1 plus the sine of theta. When you do, up top you would get 1, down below you would get the cosine of theta, and 1 over the cosine of theta is the secant of theta. And we have proven that the sine of theta divided by the cosine of theta plus the cosine of theta divided by 1 plus the sine of theta is equal to the secant of theta. All right. Now, I will also tell you that you can use your calculator. Well, you don't need to. We're not going to use the calculator to verify this, but if you were to put all of these steps in here, they would all be equal to the same output values every time, all right? And that's how you could use your calculator to check and make sure that every step of your proof is equivalent to the secant of theta. Okay, let's move on. Example number 3 says, verify the identity, the cosine of theta times the secant of theta minus the cosine of theta is equal to the sine squared of theta. Well, I don't see immediately an identity that I could use, so I'm going to go ahead and write everything in terms of cosine and sine. Well, the cosine of theta is already in terms of one of those. The secant is 1 divided by the cosine of theta minus the cosine of theta, all right, equals, all right, and then I'm going to distribute, okay? If I distribute, this times this gives you the cosine of theta divided by the cosine of theta, whoops, that's a theta, all right, minus this times this is the cosine squared of theta. But wait a minute, the cosine of theta divided by the cosine of theta is simply 1, and 1 minus the cosine squared of theta is, oh, that's from one of our Pythagorean identities. That's the sine squared of theta plus cosine squared of theta with the cosine squared of theta subtracted from each side, and that is equal to the sine squared of theta. And we have proven that the cosine of theta times the secant of theta minus the cosine of theta is equal to the sine squared of theta. All right, let's turn the page. All right, next we have the identity that 2 times the tangent of x times the secant of x is equal to 1 divided by 1 minus the sine of theta minus 1 divided by 1 plus the sine of theta. Okay, all right, well, I want to get a common denominator. And I'm going to work on that right-hand side because that right-hand side's got way more. It's got more, two terms, by the way, and there's all this subtracting, adding, and dividing going on. It's way more complicated on that right-hand side, so I'm going to work on that side. And I'm going to go ahead and get the common denominator. Well, the common denominator would be the product of the two denominators. And technically, you don't have to write it every time twice. You can just say, okay, my common denominator is 1 times the sine of x times 1 plus the sine of x. And then you can ask, well, what factor from that common denominator is missing in this first denominator? Well, that's 1 plus the sine of x. So that's what I have to multiply this by. 1 times the sine of, 1 plus the sine of x, 1 plus the sine of x, all right, minus, now by the way, you can, if you want to, put plus a negative there, which means this would be plus negative 1 times. Well, which one's missing here? If you look at the common denominator, this factor is already here, so you got to multiply that, both that numerator and denominator, by 1 minus the sine of x, all right, and that would give us, all right, I'm going to distribute up top, okay? 1 times 1 is 1, all right, and 1 times the sine of x is the sine of x, all right? I'm going to distribute over here. This times this is negative 1, and this times this is positive sine of x, all right? Down below, it's like multiplying a binomial times its conjugate. You multiply the first terms, 1 times 1 is 1. The outer product is the sine of x. The inner product is negative sine of x, and they'll cancel, all right? But the outer product is negative, and the sine of x times sine of x is the sine squared of x, all right? And anytime you see 1 minus the sine of x squared or 1 minus the cosine of x squared, you can convert those two terms into a single term. So I'm going to do that. And while I'm at it, I'm going to go ahead and simplify that numerator because these two terms would cancel each other. All right. And the sine of x plus the sine of x is 2 times the sine of x. All right. And I'm going to replace 1 minus the sine squared of x with the cosine squared of x. Okay, that's one of your Pythagorean identities. All right. Now, I'm going to then look at where I'm going because that's always what your objective is, to figure out where you're going and what you've got. Well, I've got the 2, so that's fine. I want a tangent. Well, a tangent is a sine divided by a cosine. So I'm going to just do 2 times, and I'm going to separate this over here as in the sine of x over the cosine of x, and then times 1 over the other cosine of x that I left out from that denominator. All right, and now there's the 2, there is the tangent, and 1 divided by the cosine is the secant. So I can then say that this is equal to 2 times the tangent of x, all right, times the secant of x. And I have just proven that 2 times the tangent of x times the secant of x is equal to 1 divided by 1 minus the sine of x minus 1 divided by 1 plus the sine of x. Okay, all right, let's go to number 5. In number 5, we're going to prove that the cosine of u divided by 1 minus the sine of u is equal to the secant of u plus the tangent of u. And you could probably start with either side. I'm looking, I only see one operation here. I see 2 over here. So that left-hand side looks to me like it's a little bit more complicated. So I would prefer to work on that left-hand side because it has 3 operations as opposed to just 1 over there. Okay? All right, so what I'm going to do is I'm going to multiply, I'm going to get that denominator rational or not rational. I'm going to simplify that denominator. And sometimes when your denominator is a sum or a difference, you can simplify it from 2 terms, which a sum or a difference is, into 1 by multiplying by its conjugate. All right, and the conjugate of 1 minus the sine of u is 1 plus the sine of u. So I'm going to start by, first of all, multiplying the numerator and the denominator by 1 plus the sine of u. So the cosine of u times 1 plus the sine of u divided by this current denominator, 1 minus the sine of u times 1 plus the sine of u. Now remember, these two would cancel really and give you what you started with over there on the left. Okay, all right, and now I'm going to go ahead and distribute that, all right? I'm going to apply the distributive property and get in that numerator, and that would give me the cosine of u plus the sine of u times the cosine of u, all right? And down below, I've got the difference times its conjugate. Well, the first, that's like multiplying a binomial times a binomial. Use your FOIL method. 1 times 1 is 1. Outer product is positive sine of u. Inner product is negative sine of u. Those two terms would cancel, so I'm not even going to write them down. And then the product of the last two terms would be negative sine squared of u. All right. Now, I know that 1 minus the sine squared of u is the cosine squared of u. So I'm going to immediately replace that denominator with the cosine squared of u. So the cosine of u minus the sine of u times the cosine of u, all divided by the cosine squared of u. All right. And now, this is a technique that you can do when you're verifying identities, and that is to, if you've got A plus or minus B over C, you can always rewrite that as A over C plus or minus B over C, depending on whether you have a sum or a difference. So that's what I'm going to do. I'm going to say, okay, this is the cosine of u divided by the cosine squared of u, oops, that's a u, minus the sine of u times the cosine of u divided by the cosine squared of u. All right? And now I'm going to have two terms, by the way. All right? And you can see right here, okay? Did I lose a sign? Oh, I did. Up top, this should have been a plus. My fault. This is a plus, which means that's a plus. Yeah, there we go. Okay. Now, this first term, I've got a common factor in the numerator and denominator of the cosine of u. If I divide that by that, I get 1 over. If I divide that by the cosine of u, I get the cosine of u. Plus, a cosine of u is a common factor here. If we divide up top, we get the sine of u. And if we divide the bottom by the cosine of u, we get the cosine of u. All right. And 1 over the cosine of u, well, that's just equal to the secant of u plus the sine of u divided by the cosine of u, that's the tangent of u. And we have just proven that the cosine of u, all right, divided by 1 minus the sine of u is equal to the secant of u plus the tangent of u. All right, if you have any questions verifying your identities, please email me, call me, show up in a Google Meet, whatever you need to do. Have a good day. Thank you. Bye.